Welcome everybody. So today we'll be jumping in to some of the more advanced programming concepts. We'll do a lot of multiple choice practice for the AP exam. Reduce any sound. So let's get started. There are three ways in which you can execute your programs. So you've got sequencing, which literally means that our computer is going to go line by line down the list. We have got selection, which is when your computer runs one or another condition based on what's being met. So it's like a branch in the code. And you know that you have selection when you have an if statement. And then finally, we have iteration. Iteration is when the computer will run the same lines of code over and over again. So think of that as your loops or your repeat commands. With that in mind, let's see some examples in action. Okay. Sorry, there's still a couple people joining us, but I promise we're going to get started for realsies. Share. Okay, I think you can see my screen now, which is a mess. Here we go. These are the slides that you should have with you. We've got a lot to cover. Present. Great. So the first thing we're going to cover is a for loop. And it generally looks like this. For each n in list, this n here represents the variable, and then list represents the list that you're working with. And what this does is we'll iterate over each value in the list. And when we say iterate, remember that means we're going to loop and we're going to simply visit each value in the list. N, recall, is the value of the element in the list. If that doesn't make sense right now, don't worry. Let's see an example. So this is my list here. So if I say for each n in list, then on the first iteration, my n will be 2 because n represents each value in the list. And the second iteration, n will be -5. On your third iteration, n will be 8, then 4, then 0. And those are the values that n takes, one at a time in order. You could also loop over a list of strings instead of integers. So on the first iteration, n would be the string Sam, then Joe, then Bree. Important thing to note, when you see something of this form, list bracket, and then a number inside, that bracket notation indicates that we will be indexing into the list, meaning we're going to go to the nth item of the list. So if I see list bracket 1, that means go to the first item in the list. So let me ask you this. What's list bracket 1 of the first list? What would the value be of list bracket 1 for the first list? The value would be 2, right? What's list bracket 2 of the second list? List bracket 2 of the second list would be Joe, because I said bracket 2, so we were talking about the second element, right? So for instance, list bracket 1 is 2, list bracket 5 is just the fifth item in the list, 1, 2, 3, 4, 5, it would be 0, and so on. Nothing crazy happening here. Just keep in mind, if you do use a programming language where they start at the 0th item, that is not how the AP exam works. The AP exam uses a pseudo language where the first item in the list is index 1. So it's 1, 2, 3, 4, 5 when we talk about indexing. All right, let's get into our first algorithm. There's a number of algorithms we'll review today, 5 total. We'll start with the simplest one, which is our counting algorithm. So oftentimes in programming, you'll find yourself needing to count the number of items in a list, or generally in life, we like to count things. It's one of the first things that we do, that we learn when we are babies, right? Okay, so how do we count using an algorithm? Well, we're gonna follow this basic algorithmic setup. So I'll give you 30 seconds to write it down. and then we'll discuss and see it in action. Notice we initialize a variable at the top called counter. And we initialize it to 0 because naturally we'll start counting from 0. We haven't counted anything yet. Then for each n in list, n being the value, the items, so n will go as high as the number of things that there are. If there are 5 items in the list, n will become the 5th item. Well, for each of them, we're going to take our counter right here, add 1 to it, and then store that in our counter. So basically what this means is add 1 to your counter. And we're not going to stop there. We're going to do that multiple times. How many times? Well, however long our list is, because we're going to do it for each n in list. Let's look at an example. Let's say that this is our list. Okay, write it down, 5883, and also take down the algorithm. So the list is 5883. And I'm pulling up my iPad so that we can do some work together. Okay, so here's how it will work. If you've been in a session with me before, you know that I like to teach a very specific way of program tracing. So follow my lead. On the first line, we're initializing our counter to 0. So let's show that off on the side. Counter equals 0. Next, for each n in list, counter gets 1. So let's go. Right now, n is equal to 5. So for that number, we're at here right now, we're going to add 1 to counter. So counter is 0, adding 1 gives us 1, and we're storing that back in counter. So that's why I updated it. Notice that we didn't use the number 5 at all. We don't care what the numbers are. We just want to use them to know how long we should keep adding to our counter. So we've gone through the first element in the list. Now n is equal to 8. We're here now. So that's what the for loop does. It just keeps going back and forth. So we're going to add 1 to counter, making it 2. Store that in counter, and then we go now to the next n in list. Now my n is 8 again. So what do? I add 1 to my counter. Next item, we're at the 3 now. So right now n equals 3. Counter gets 1, so this becomes 4. Storing that in counter, I did that. And now we are done because we've gone through each item in the list. We've now exited the for loop and we'll display counter. So counter did exactly what we'd expect it to do. It literally counted. It went, hey, that's 1, now our 2, that's our 3rd. Now we have number 4. That's our first algorithm. Any questions before I move on?
In the exam, it starts with index 1, right?
Yes, it starts in, so if you see list 1 or the name of the list followed by bracket 1, this is representing the first item in the list. Correct. Good question.
Thank you.
All right, let's go to our second algorithm, which is to calculate the sum or total. Go ahead and copy it down. Oh. All right. So notice here, instead of setting counter to 0, we're setting sum to 0 because we want to use variable names that make sense. So what does it mean when we are finding the sum? Sum just means we're adding everything up. That's the sum. Okay, so we're setting our sum to 0, and then for each item in the list, we're not going to add 1. Remember before it said counter plus 1? We don't want to add 1 for each thing. We actually want to add n itself. We want to add the value to our sum and keep adding to that sum until we're done. Let's see it in action. So let's go. Sum initialized to 0, check. Gonna write it over here. Then we start our for loop. For each int, notice I'm using a different word. It doesn't matter whether the word is n or int or starfish. It just refers, it's a temporary variable that will refer to this item in the list. So right now, int is 5, and we're gonna go through each item in the list. Well, what do we do on our first loop? We're gonna take sum, which is currently 0, and add int to it. Well, what's int? On our first iteration, int is 5. So we're gonna add 5 to 0 and make that our new sum. We've gone through the loop one time. Now let's go again. This time my int is gonna be 8. So I'm going to again take my sum, which this time is 5, and add int to it. Well, int is 8 right now. So 5 plus 8 gives me 13. Do you see how this is fundamentally different from the previous example? We were just adding 1 last time. Now we're actually adding the values. So we finished our second loop. Let's go back to the for loop. Now int is the second 8. So sum, which is 13, I'm here right now, sum, which is currently 13, adds int, which is 8 right now. So 13 plus 8, that's 21. Next for loop. Now my int is not 8 anymore, it's 3. So int right now is 3, so I'm gonna add sum and int together. 21 plus 3 is 24. Storing that in sum. Okay, now I'm done with my loop. There's nowhere else to go. There are no more ints in the list. So we simply skip, display the sum, and 24 is what this program will give us. And indeed, if you add up 5 plus 8 plus 8 plus 3, you do get 24. So have a look at that. Let me know if you have any questions now. We're gonna get more practice with these side by side. So the key difference was in what we added to our variable. Remember, in the counter, when we were just counting things up, we just added 1. Hey, for each element, just add 1, just keep adding 1, because that's how we count. We go 1, 2, 3, 4. But when you're adding a total up, you want to actually use the value. That's why we added int. Notice that, so you don't have to write this down. Instead of using the word sum here, I just used total here and here. And it's totally fine. No pun intended. You could use any word to keep track of your sum. All right, let's do a practice problem. Or actually, before we do a practice problem, let's do this. Look at each, let's call this algorithm A, let's call this algorithm B. In a couple words, I want you to, yes, wait 1 second, Kevin, yeah, whatever it says after the word each, whether it's n or int, or it could say value, or it could be score, or if it's a list of ages, it might say for each age, whatever it is, it's just a variable that represents the value itself, 2, -5, 8, 4, 0. Okay, so what does A do and what does B do? Ready? Take 30 seconds and think about it, but don't hit enter until I say go. See if you can figure out what each of these algorithms is doing. And this pseudocode is designed to be exactly like the AP exam. They use these words like for each, display. So have a close look. What is each algorithm doing? In your chat, I want you to write A and then a word or two describing what it does, comma, B, a word or two describing what it does. That format. 10 more seconds. Don't hit enter till I say go. Three, 2, 1, go. All right, have a look at the answers. Yeah, so A is basically a counter, because for each item in the list, for each thing, we're just adding 1 to our variable x. And notice x starts at 0. So if I start at 0 and then for each of these I add 1, all I'm doing is counting, and I'm going to end up with x being 5. Whereas our B algorithm is finding the sum. It's also starting at 0, but then for each thing it's adding the actual value. So it's going to go 0 plus 2 plus -5 plus 8 plus 4 plus 0. Whatever that is, that's going to be the answer that's displayed. Hopefully that made sense. Yes? Great. Let's do an AP practice problem. Okay. So it says a programmer wrote the program below. The program uses a list of numbers called numList. The program is intended to display the sum of the numbers in the list. So here's our code. In order to test the program, the programmer initializes numList to 0, 1, 4, 5. So that's the list we're working with. The program displays 10, and the programmer concludes that the program works as intended. Which of the following is true? Look carefully at the code, look at all the answers, and in 1 minute, you're going to submit your answer A, B, C, or D, but do not hit enter until I say go. Give everybody a chance to think. So 1 minute on the clock. The slides for anybody who was asking about them. Ten more seconds. 4, 3, 2, 1, go. Type in your answer in the chat. All right, Nelson, you got to make a choice. Is it A or B? I see A's, B's, C's. Let's go over this. So in the first of all, it says that the sum is 10. So I'm just going to do a quick check. 0, 1, 4, 5, adding them all together gives me 10. So I know that the sum should be 10. The conclusion is correct. The program works as intended. Let's see. So how does this program work? First, it's starting our sum at, let's start this from scratch. It's initializing sum to the first element of the list. What is the first element of the list? What is sum equal in the beginning? Yeah, 0. It's the first element in the list right here. So it's setting sum to 0. And then it's going to, for each value in the list, so right now value is our variable that is equal to 0. It's going to add the value to sum. So it's going to add 0 to 0, which is 0. It's then going to add 1 to 0, which is 1. Then it's going to add 4 to 1, which is 5. And then it's going to add 5 to 5, which is 10. So you might think it works, but why? Manav, come off of mute and explain why this is actually an incorrect algorithm. It just so happened to work this time.
Okay, so because they created sum as the first item of the list, like let's say it was 8, for example, then they would be initializing sum as 8, and then when they first start the for loop, it would be sum, which is 8 plus the first value, which was also 8, which would make 16. And you don't want to add the same number twice. You want to add each number to themselves.
Yeah. So
it only worked.
Go ahead.
It only worked because 0, if you add 0 to 0, it makes 0. So
thank you. Well said. Well said. So it only worked because the first item in the list was 0. It just so happened to work. But when you start counting things up, you don't start from a random number like 8, for instance. If we were to run this code on the list 832, it would double count 8, as Minav said. It's going to start it at 8, and then it's going to add each number. It's going to add 8 to 8, then 3 to whatever that was, and then it's going to add 2. So looking back at our pseudocode, notice we always started our sum initializing it at 0. You always want to initialize your summing variable, your aggregator variable, the thing that's going to hold everything. You want to start it at 0. Never another number, and definitely not the first number in the list. So the correct answer here was C. The conclusion is incorrect. Using the test case 0145 is not sufficient. If you used a different list, it wouldn't have worked. Thumbs up if that made sense. Oh my God, didn't make sense for anybody. I'm just kidding. Okay. Well, if you have questions, let me know. Let's move on to our next algorithm. So what'd you learn? When you want to count things, when you want to sum things, always initialize your variable to 0. Now let's calculate our average. So this is a very common algorithm. You want to find the average of a set of numbers in a list. 30 seconds to get it down, and then we'll jump in. So to calculate the average, notice that we need 2 variables this time. We're going to keep track of the sum because we want to take the total, add it all up. And then we also want to keep track of the count. Why? Because when you find the average, you take the total and you divide by the number of things that there are. So we need the sum and a counter. We're putting algorithms 1 and 2 together. And then we begin our loop. So for each thing in the list, we're going to add the value, the actual number itself. We're going to add that to our sum and keep adding them all up. And then for our count, we're simply just going to add 1. So for each thing, we're just going to add 1. In the last step, what am I doing with these 2 numbers? We're going to divide them, just as you would imagine we would to get our average. Let's see it in action. I have the same list, 5883, just for pedagogical purposes, which means teaching. That's a fancy word for teaching. And so let's see it in action. So I'm going to initialize my sum variable. Oops. I'm going to initialize my sum variable to 0, and count gets initialized to 0. Check, check. Notice that I always initialize my variables before the for loop. You want to set them up and then you begin looping through the list. So for each, this time the variable is called score. So for each score in list, all right, so right now score is 5. We're going to do this 4 times. Right now score is 5. I'm going to add the score to my sum. So sum gets 5 added on, and then I'm going to add 1 to count. So count just gets 1 added on. Great, that's 1 loop. Let's move on. Now score is 8. So 8 gets added to my sum, giving me 13 as my sum, and then 1 gets added to my count, giving me 2. So remember, for each thing that we go through in the list, we're going to do both of these since they're indented. Okay, next loop. Score is now this 8. Add it to my sum, add 1 to count. Final loop through the list. Score is now 3. That's my last score in the list. So 3 gets added to my sum, 1 gets added to my count. I'm done. There's no more scores in the list. So I'm going to move to the final statement and display sum divided by count. So 24 divided by count, which is 4, and it's going to display 6 as our final answer, which is indeed the average of the numbers in the list. Like magic. Now I want to see, Actually, that's about it. Okay. Let's take another second. This is the same exact code that you're looking at right now. Sum is initialized to 0. Count is initialized to 0. We iterate through each n or thing in the list, doing our sum aggregator, doing our count. The only difference this time is instead of displaying sum divided by count, I'm going to do sum divided by count and store that in a new variable called my average, because it's easier for somebody else who's reading my program to understand what's happening. You're telling them this is the average. And then in the last step, you display average. It's the exact same code, just a little bit more readable. Thumbs up if you're ready to move on. Otherwise, I'm accepting questions. Okay. All right, here is an AP exam question. Ready? A programmer wrote the code segment below to display the average of all the elements in a list called numbers. There is always at least one number in the list. There's the code. It should look familiar. The programmer wants to reduce the number of operations. Okay, what do I mean by reduce the number of operations? Really quick. When we were doing these problems, every time I added 5 or added some number, that's an operation. So up here we did 1, 2, 3, 4, 5 operations. We also did 5 operations for count anytime that we do a math operation. And then we did a final operation to do this division. So maybe like 11 operations total. Basically, how many math problems do you have to do? Okay. So this person wants to reduce the number of operations that are performed when the program is run. Which change will result in a correct program with a reduced number of operations performed? Have a look at the code carefully, look through A, B, C, and D, and in 1 minute, you'll share your answers. Don't hit enter till I say go. All right, 10 more seconds. Three, two, one. Share your answers. All right. So I'm seeing a mix of responses, but a very heavy emphasis on D. Just quickly, let's see. A is wrong because if you just exchange these, it's not changing the math operations you're doing. You're just doing them in a different order. You still have to set count to 0. You still have to set sum to 0. Same with lines 5 and 6. You're just changing which you do first, but they're still going to each happen for each thing in the list. Same with lines 6 and 7. And the answer here is D. Interchanging lines 7 and 8. Can anybody come off of mute and just explain what's the problem with having this operation at this spot and why it would be better for it to be in line 8? Anybody want to jump off? Yeah.
It would be better to be on line 8 because after you finish counting and adding the sum, you would have to divide it and then start over again.
Yes.
And then once you're going to have to display it.
Yes. So You don't need to keep starting over and dividing it every single time. Somebody want to build off of that?
If
What-
you put it,
Go ahead. You're on.
if you put it in line 8, you can, because you don't need to run it through the list every single time, because after the list ends, then you can divide it. If you do it every single time, you're just increasing the operations.
Yes. So exactly a combination of what you guys said. If I count basically calculate the average, that's fine. You could calculate the average. Right now, it's going to do it each time for each number. It's going to say, this is my average now. And then on the second loop, it's going to say, now this is my average. And now this is my average. But we don't care about figuring out the average every single time as we move up the list. We only want to count the final average. Once we've done all the counting and all the totaling, we only want to calculate the average once. And so it will save us a number of operations if we move our average calculation here instead. And so that is, if you have a look at our previous example, that's where the average calculation took place, was outside the loop. It doesn't need to be updated every time. Excellent. Let us move on to our fourth algorithm. Thanks, guys. I love hearing your voices. I can't say enough, like how much more fun it is to teach when you guys are involved. All right, fourth algorithm. Now we're not counting things, we're counting specific instances in a list. So we're counting things that meet a certain criteria. So write this down, copy down the algorithm. This is our general setup. So we're still counting, but what we're counting is different. So we're going to start our count at 0. And then for each thing in the list, we're going to check if that item is what we're looking for, if n equals target. And I'll show you an example of what that means. Just or Manop, I'm going to mute you. Now, if that condition is satisfied, then I'll add 1 and I'll display count. Let's see this in action. Okay, so I'm initializing my count to 0. If you didn't finish copying the previous example, this one is just as good to copy down, except instead of n, I'm using the word value. So notice I'm checking if the value meets my criteria. So I'm starting count to 0. Let's write this down. Now for each value in list, that's the cue. That means I'm going to loop. So first, my value is 19. And I'm going to check if the value, what's the value? It's 19 right now. So if the value equals 18, then I'll add 1 to the count. Well, let's see. Is 19 equal to 18? No, it's not true. So I'm going to skip. I'm done with my first iteration of the loop. So I go back to the beginning of the for loop. So notice I did not count that 19. Let's move on. Next iteration. This time value is 18. So if the value equals 18, which it does, 18 equals 18, what am I going to do? I will add 1 to the count. So now we've updated. Okay, next iteration, back to the for loop. Now my value is 16. If 16 equals 18, I'll add 1 to the count. Well, 16 doesn't equal 18, so we won't do anything. We'll simply go to the next iteration. We're at 18 again. If the value equals 18, which it does, I'll add 1 to the count, and so on and so forth. So 20 is not equal to 18, skip. 17 is not equal to 18. It doesn't satisfy that condition, so skip. And our final count is 2. So in simple language, you can see that this is counting how many 18s there are. If this was a list of ages, it's saying how many 18-year-olds are there in this database? There's 2 of them. And this is how we would algorithmically find that. So if you're looking to count instances of something specific, you need to include an if, so you can check if the item meets the condition for what you're looking for. Let's look at the next example. Just look at the code And type into the chat for me, what is this algorithm counting in a sentence? If this is line 1, this is line 2, this is line 3, that's line 4, and that's line 5, you want to focus on line 3. What are we counting? What are we looking out for in this version of the algorithm? Exactly. The amount, we're counting how many numbers are greater than or equal to 18. Exactly. If the value satisfies this condition, if it's greater than or equal to 18, then we'll add 1 to the count. So just by looking at our list, what should our algorithm spit out at the end? 4. It's going to add 1 for this guy because it's true. It's going to add 1 for this guy. It's going to add 1 for this guy. And it's going to add 1 for 20 as well. They all make this condition true, meaning we will execute the next line. Okay, you guys tell me, what will this algorithm spit out? I still haven't seen the right answer. Kumar, why? Why 0?
It's 0 because it's lowercase Joe in line 3 and it's capital J in the list.
Yes. Oh my gosh, so picky, right? Our computers interpret us literally. Yeah, this is going to check if capital J-O equals lowercase j-o, and it's going to say, no, they're not the exact same. False. So this would return 0. I know. Keep an eye out, okay? Let's look at the next one. What would this algorithm spit out? So focus on the if statement to see what it is that we're looking for. All right, what would this algorithm give us? Sorry, you want to share? Why 0?
It's looking for both Joe with capital and one with lowercase. And since there's only one with uppercase and not with lowercase, it doesn't work out.
But here's the uppercase, so I don't understand. Because last time we only had lowercase.
Which means that it needs the lowercase too.
Yeah, so it's saying, okay. I have a question, sorry, stay on. What if I added another name here that was lowercase J-O? Now would it work?
Yeah, it would work if it did have that one.
Thumbs up if you agree. Thumbs up if you agree it would work. Okay. I'm seeing some mixed response. All right, Noah, come off of mute. Why do you disagree?
I disagree because it's asking for the name to be both an uppercase and a lowercase. It's only for one term. So in that situation, regardless if you add in a lowercase Joe, it's not going to suffice. However, if you change the and statement to an or statement, it'd be true. And then you would get a 2 for your answer, or for your result. That's what I mean.
So really, really picky, right? And versus or. If I say for each thing, check if the name is capital J-O and that same thing. We're still on the same item. Let's say we're on this guy right here. It's going to be true for this, but if you have an and, both things need to be true. So it's going to say, is it capital J-O and lowercase Joe at the same time? Well, of course, that's impossible. We can only have one thing at a time. And so that's why this would give us a count of 0 no matter what, because this is faulty programming. You don't want to check if one word is 2 different words at the same time. Impossible, okay? So what should we change it to? As you said already, an or. An or would work here. So if now I want to count how many Joes there are, recognizing that someone might do capital J or lowercase j, depending on how they type in. Let's say it's like a username, or password is not a good example because it's case sensitive. But then you might want to use an or statement to check, hey, it could satisfy one or the other of these conditions. Now count would give us 1. All right.
I have a question about the previous one.
Yes.
So let's say it was capital Joe or name equals like say capital Sam, like just the Sam. Would count still be 1 or would it be 2?
What do you think?
Uh,
Let-
I thought it was 1, but then I think someone earlier said it was 2, so
Let's-
I was confused.
Go through it. This is Manav, right?
Mhm.
So let's go through it. So first count is going to be 0. Then it's going to say for each name in list. So right now name is Sam. I'm going to check. So right now name is Sam. If the name is Joe, okay, that's false. Or the name is Sam. So is this whole statement true or false? Was it one or the other?
It's true, yeah.
True. So since one of those conditions was true, the whole statement is true. That's what an or does. So we will add 1 to count. And now we go back to the for loop. Now the name is Joe, and we're going to do the same thing. Is the name equal to Joe or Sam? Yep, it's equal to Joe. So the statement is true again. So it's going to add 1 to count. And then it's going to check Bree. Is Bree Joe or Sam? No. So we're done. It's going to count 2. So this guy is going to count how many Joes or Sams we have.
Okay.
Good question. All righty. Let's do a AP exam Q. I'm going to skip this one because it's a little on the easier side. Okay, here we go. The program below is intended to count the number of prime numbers in a list called numbers and display the result. The program uses the procedure is prime n. All that means is it's going to take in a number n, and then this is the is prime algorithm. It's just going to run it through this, okay? Which returns true if n is a prime number and false if it's not. Okay, well, this is the code inside. It doesn't work as intended. Which 2 lines of code should be removed so the program will work as intended? Keep in mind, what we're trying to do is count the number of prime numbers in a list. Select 2 answers. Which 2 lines should we remove? 1 minute on the clock. Don't hit enter till I say go. So you're going to type in your answer like A, comma B or C, comma D. Ten more seconds. And submit your answer in 5, 4, 3, 2, 1, 0. All right, I'm seeing a lot of B, Ds. Oh my God, you guys just give me a thumbs up. That's so nice of you. That's so nice. All right, let's see. Well, we want to see line 1 and line 4 look redundant. One of them should go. And then line 7 and 9 look redundant. One of them should go. So line 1 starts our count at 0. Whereas line 4 starts our count at 0 inside the for loop. Why is that hurtful? Why is that damaging? Well, if you're trying to count for each item in the list, if it's prime, let's just think about what happens if you let's say count and you're at 1. You've got one so far. Okay. So count was 0, but then it became 1 because you found a prime. Then you come back to the for loop, and then what do? You have to do everything that's indented for each item. So what are you going to do? You're going to set count back to 0. It's like having short-term memory loss, and you just keep forgetting your count and setting it back to 0 every time. We've never done that before. Every single program that we've done so far, we initialize our count before the loop, even back to our average. We initialize count and sum before the loop. We never want to set it to 0 in the middle of counting. Okay, so definitely line 4 should go. Bye-bye. What else? Line 7 is good because if the number is prime, then we add to our count. But line 9 says, whether that's true or not, you're going to add 1 to the count. So even if the number is not prime, let's say that we got a number that's not prime, like 10. 10 is not prime, right? So it's going to skip this line because it's not prime, so we're going to skip. But then it's still going to add 1 to the count. So if you want to count only prime numbers, then you should only add count inside the if statement if it's true, if it is a prime number, which is why looking back at our algorithm, our setup right here, it is initializing count outside and then only counting inside the if statement if it's true. Otherwise, you're just going to do a regular count. Not very helpful. Okay, so that was good. Good job. What do we want to do now? Okay, here we go. No. Okay, last section. Okay, we're going to end with finding maxes and mins. So write this down. We're going to start by finding the max. So you have a list of numbers and you want to see what's the maximum number in the list, right? What is the most profitable company? Look at all the revenues and find the highest one. Who's the oldest member? Have all the ages, find the highest one. So that's all finding the max and min is. So notice that we initialize max, and then for each thing in the list, we're checking if. So we've seen this before. If n, which represents the thing in the list, is greater than whatever max is, then that becomes our new max. That's what's happening on line 4. We're setting a new max to be whatever was that number that was greater than it. Okay, let's just jump in with an example. So list A, let's run it. We have the numbers 3 and 8. Let's see how this works. So we're going to set max equal to 0. And for each n in list, so we're starting with 3. N is currently 3. We're going to do lines 3 and 4. Okay, if n, which is 3, is greater than the max, which is 0. Guys, is this true or false? True. 3 is greater than 0. So we'll set max to be our n. So we're going to take n, which is 3, and make it the new max. So far, so good. Now n is 8 instead. Okay, next iteration through the loop. All right, we finished the inside. We're back to line 2. So now n is 8. So it's going to check if n, which is 8, is greater than my max, which is now 3. Is 8 greater than 3? It sure is. So take n, which is my 8 right here, and make that my new max. Ta-da! We're done iterating through the loop. There's no more things in the list, so it's going to display 8. It seems to work. I want you to run that same algorithm on list C and tell me what happens. So take 30 seconds and run the algorithm through list C. So tell me what happens. Did it work or no? If you run the program, you'll see it doesn't work. What seemed to be a good algorithm actually fails here, and let's see why. So for this example, we're starting max to 0, and then for each n in the list, so now n is -3, it's going to check, is that number greater than my max of 0? Well, -3 isn't greater than 0. It's less than 0. So because that's false, we're going to skip line 4 and go back to my for loop. Now it's going to check with n being -5. Is -5 greater than my max of 0? Again, no. -5 is not greater than 0. And since that's false, again, remember, we'll only do this if we got a true. Since it's false again, we skip, and then we're done with our for looping, and it's going to give me a max of 0. So that was totally wrong. It was totally wrong. So now you're learning something new. If you want to count, or if you want to add, you should initialize your count or your sum variables to 0. But if you want to find the maximum or the minimum number of a list, don't use 0, because 0 ended up being bigger than any of our numbers, and it's not even in the list. So instead of using 0 to initialize our max, we will initialize our max to whatever is the first item of the list. That way we make sure that our max is at least in the list. And then we just compare all the numbers to the first item in the list. So for example, so I would like you to cross out what you had before and write this instead. That's how you initialize the max or the min. You set it equal to list 1, list bracket 1. Let's calculate the min. Notice the only thing that's different this time is instead of checking if we're greater than, we're going to check for the minimum value. So we want to see if we're less than. Okay, but let's run it on list C. Okay, so let's start with min. Min is being initialized to list bracket 1, which means the first item in the list. So n is currently -3. So for n is -3 right now, if it is less than my min, oh wait, sorry, I haven't even initialized it yet. There, now I did the first line. Min is -3. Now, for each thing in the list, and the first thing is -3, I'm going to check if it's less than my min. Well, -3, that's my n currently. We're comparing it to -3. That's not true. That's false. You can't be less than yourself. So because of that, we skip this and we go to the next iteration in the for loop. But that's fine because we already have the -3 taken into account. So now we check -5. Is -5, that's my n. So right here, -5, is that less than my min, which is -3? It is indeed. -5 is less than -3. So since this is true, we will do that line, which says take n, which is -5, and store it in your min. So min gets changed to -5. And since we're on the last item in the list, there's no more looping to do, and we'll display our min of -5. We did it. We did it. So there you go. That's finding all of the algorithms that you'll see on the AP exam. Okay, we're going to end with a 5-minute lightning round. By the way, any questions on what we just did? Did that make sense? BD if you're good. PQ, which is our thumbs down if you're not good. PQ is a thumbs down if you're not feeling good. Thumbs up, thumbs down. Okay, great. So now that we've covered all the algorithms, wow, that was so fun. Now let's do a quick lightning round, and I want to get you out by 6:04. Okay, I'm so sorry. I'm so sorry for keeping you. But we've went over this before. There's sequencing, selection, and iteration. Anytime you see an if statement, you're dealing with selection. Anytime you see a repeat or a for loop, you're dealing with iteration. And if neither of those is present, you're dealing with sequencing, which just says, hey, just do each line by line. So here's a common question on the AP exam. It says, what do you see? So guys, have a look. What do you see here? Just type in sequencing, selection, or iteration. You can type in the shorter versions like this, seek, cell, or iter. Okay, so this one's going to be selection. I mean, there's always sequencing going on, of course. But if you see something else, I want you to say the other thing, okay? So this one's going to have selection, right? We have an if statement. Excellent. Let's move on. What do you see here? Sequencing, selection, or iteration? So while, that's a type of loop. So what do we have? It's a type of loop. So therefore we have iteration. Awesome. Let's go to the next one. All right, go. Look at the code. Do you see selection or iteration? This one is going to be selection. We have an if statement, so we're selecting either branch A or branch B. How about this one? Sequencing, selection, or iteration? This is sequencing. There's nothing that's interfering with our code. It's just going to go line 1, line 2. It's just going to print, print, print down the lines. That's sequencing. Another, quick, go. Selection. Next one. This is our last one. Good, that's just sequencing. It's setting the radius to 5, it's setting pi, it's gonna calculate the area. There's no ifs and there's no looping. Okay, now with all that, remember if else, if and else, those are all examples of if, that's selection, because you're gonna select yes or no, select a path. And if you see any of these, what are you dealing with? Yes, excellent, iteration. All right, so here's the AP question. An algorithm has been developed to compute the sum of all the elements in a list of integers. Which of the following programming structures must be added to the existing algorithm so that the new algorithm computes the sum of only the even integers? So 30 seconds on the clock, don't hit enter until I say go. Again, a current algorithm computes the sum of all the elements in a list of integers. Which of the following structures must be added so the new algorithm only sums up the even integers? 10 more seconds. 5, 4, Tiffany has 3, 2, 1, go. Yes, we need to add some selection. The reason why we don't need to add iteration is because we already are computing the sum. So it already has a loop. So if we want to only calculate the even integers, right? Oh, this is the sum that it started with. It already has a loop. But if we want to calculate only the evens, then we need to add this if. And remember, if your value mod 2 equals 0, that modulo operator basically says what's the remainder. So it's saying if you take a number and you divide it by 2 and you get a remainder of 0, that's how you know it's even. All right, let's look at another one. Which of the following algorithms requires both selection and iteration? 30 seconds on the clock. Which of the following requires both selection and iteration? Okay. 3, 2, 1, go. Okay, so this is a select 2, so everybody select 2. I'm seeing mostly B's and C's. All right, let's see. So A, an algorithm that displays the greater of 2 integers. All right, why? That's like our max, right? That's like our max algorithm, which did have loop and it had a selection. The reason why this doesn't work is because if you only have 2 integers, you don't need to loop. You can just say, if you can only have an if, you can have just one if statement. If this is greater than this, there you go. So that's why A is not the correct answer. But B says a list displays the number of even integers. So it does have to check if the number is even using that statement. So that is correct. And then again, list of integers, meaning we have to loop, displays only the negatives. So that means we're counting instances in a list. So it's going to be like if n is less than 0, that's how we'll tell if it's negative. Therefore, we have iteration and selection. But D is wrong because if you just display the sum, you don't need an if. You don't need to select. You just simply add, add, add. Right? So this is the example of showing just the greater of two things. Notice that there's no iteration. There's no looping. If A is greater than B, display A. Otherwise, display B. And then this was D, the summing of everything in the list. There's no selection required, okay? Whereas this is our selecting only the even integers and counting them. And this is selecting the negative values and counting them. All right, great job, everybody. This has been wonderful. I hope you learned a lot. All right, let me hear you say bye before you leave. Bye.
Bye.
Hey guys.
Bye.
Bye. Good luck with everything.
Bye.
Bye.
Miss,
Yes.
I wanted to ask a question about the written exam.
Go ahead.
Okay, on one of the questions, it says that you had to explain your algorithm. And then I wanted to make sure that when it's talking about algorithm, it's talking about the different types of algorithm we were talking about, right? Like selection.
Yeah. Yeah.
Oh, okay. That's all I wanted to clear.
That's it?
Yeah.
Yeah, so when it says display your algorithm, basically what is the block of code that you have in your program that is doing some selection and some iteration is essentially it. That's how if you read the documentation, the rubric for how you get the point, actually